Here's how you find the greatest common factor and the least common multiple when you're dealing with rather large numbers. The first thing we're going to need is the prime factorization of each number. The prime factorization of 18,000 is 2 to the 4th power times 3 squared times 5 to the 3rd power. The prime factorization of 31,752 is 2 to the 3rd power times 3 to the 4th power times 7 squared. To find the GCF, we're going to write down all the prime factors that these two prime factorizations have in common. So they both have 2's, we're going to use a 2, and they both have 3. So let's start with that. We need a 2 and we need a 3. Now, only the 18,000 produced a 5. We're not going to use that. And only the 31,752 produced a 7. Because they don't have these numbers in common, we're not going to use the 5 and we're not going to use the 7 for the GCF. Now, looking at the exponents of the prime factor 2, for the GCF, we're going to use the smallest exponent. And here, that is 3. So we're going to use 2 to the 3rd power. Looking at the 3's, the smallest exponent is a 2. So that is what we'll use for the GCF. 2 cubed times 3 squared gives us 72, and that is the GCF of these two numbers. Now the LCM is the opposite of what we just did. For the LCM, the least common multiple, we're going to use all the factors, not just the ones that they have in common. So we're going to use 2 and 3 again, but this time we also get to use the 5 and the 7. And as far as the powers go, we're going to use the largest exponent for each prime factor. On the 2's, the largest exponent is 4. On the 3's, the largest exponent is also 4. Well, there's only one 5 to choose from, and that has an exponent of 3, and then the exponent on the 7 is 2. You type this into a calculator, and you're going to get 7,938,000. And believe it or not, that is the least common multiple of these two numbers.